Hey folks, Ben Brandt here, back at the workbench with kind of a fun project to share with you. This here is a mysterious looking doomsday device. Not real, of course, but there's a lot of fun stuff going on in here because while it's a locked box, I can unlock it over the internet. So, a little bit of background here. I actually built this for a company holiday party earlier this year. So the basic premise of this thing is that everybody that was invited to the party got to play the role of a spy trying to infiltrate the party and deactivate this mysterious doomsday device. Hence the theatrics with the blinking lights and the big red button. Now at the party, the guests would progress through a series of games and puzzles, each one revealing a different word. You put all those words together, you got a secret passphrase, and once you get to the end of the game, you pull up a website on your phone, enter the passphrase in, that signal goes out over the internet and unlocks the box, and you are one of the winners of the game. So, it's kind of a fun concept. Now you might be thinking, we can't have parties. I can't build this for a party right now. We're all on lockdown. Fair point. But this was built back before all that happened. And there's just too much fun stuff going on in here not to share with you all. So there's a lot of different processes and systems, electronics, and making that went into producing this briefcase here. So I think the best way to share that with you is we're going to tear it all down and start putting it back together, and I can talk you through all the parts inside and how everything works, and hopefully we can inspire you to come up with some other fun ideas of stuff you can tinker with and maybe fill some of the extra time you might have right now. So let's dig in. Okay, I think this is about as far as I'll tear things down for this video. So let's talk a little bit first about this case. The whole concept of this thing was reliant on finding some sort of briefcase with one of those spring-loaded combination locks. So there used to be a combination lock here. I actually have a lot of the pieces left over here. So here's one of the number wheels. Here's the housing panel that was on the front. So that sat in here. You would lock it. Turn the dials for your combination, slide a little button over, and this would pop up. So I needed a case that opened that way so I could modify the combination lock so I could move it with a servo from my electronics. And this is actually just a cheap storage case that doubles as a clipboard, but it had that sort of black with aluminum edging look that looked kind of cool, and it just worked out well for this project. Now on the inside here I've got a little bit of a wood frame that holds the panel on the top. That was just screwed in from the bottom, and I've got some just reflective tape here so it didn't look quite so weird when the wood color showed through the top plastic. But there's a little slot back here to hold the battery. This case, the battery, almost all the stuff here can be found on Amazon. I'll include links to all this stuff if you're curious to dig into some of these things. But this battery is great. It's super high capacity. It's got a couple USB ports for charging items. But for low power hobby electronics projects, this thing will run for days. So charge this up. I've got it built so it can slide right in here, and it's snug and won't go anywhere. So that powers our whole project. So I want to make sure I had a case big enough to hold the battery and some room for electronics. And there we go. Now, one other feature here, which I thought would have been a cooler feature. I was originally going to get one of these pneumatic air cylinders that I found on eBay. So when you close it and release the lock, this air cylinder could open it for you. but when I installed it in here, it was pushing too hard, and it sort of tweaked the whole lid to one side, and it just bound up. The hinges aren't very strong back here, so I had to ditch the air cylinder so it wouldn't open by itself, and replaced it with some chain so it wouldn't just flop all the way open. On the front here, this is the original cutout for the lock. And I'll show you here in a minute. I modeled all of this up in Fusion 360 so I could recreate the placement of the slot for the lock and the mounting holes, and then I designed a whole new panel to go on the front to line up with the lock and give me a little window here for LCD screen to display some numbers. That was one of the things, is I wanted to display a 4-number code, so you had to physically find the briefcase first, enter in the code, and then enter in the passcode to pop it open. So I wanted to make sure you were within sight of the box. One other thing on the case here, you can see I've got a little bit of a red window here to cover up the LCD screen. That actually came from one of these lunch meat container lids. So I just cut one of those out, pop that in there with a little super glue. Okay, now just a closer look at this front panel here. This was designed to match up these mounting holes with these original mounting holes and the slot for the lock, so they would end up in the right place. Now, the one piece that I saved from the original combination lock, flip it over here, this is the piece that slides out of the way to let the lock pop open. So when this slides over, the lock can release, and then it slides back, and it's locked again. So I saved this one piece, as I didn't want to have to recreate this nice smooth curved shape that was designed to work really well with the latch. And cut a couple pieces of aluminum here to kind of hold it in place and screw it onto the front panel. And I've just got a little spring here connecting to this piece. Now if you look real close here, there's these 2 square tabs that were part of the original piece. And I got out the Dremel here and drilled 2 tiny holes. One to hook in this spring to pull it back shut. So when I go like this, it pulls it back. And this other hole here, I hook up to my servo. So when the servo pulls it back, it unlocks. Now the front panel itself, I was able to cut out most of this with the help of a CNC, though probably didn't have the right bits for it. I still had to clean some stuff up with a file, open up this slot a little bigger because I didn't have it quite the right size, and cleaned up the edges on the table saw and sanded them. But it turned out pretty nice. So let's attach this on the front. And pretty much everything here is put together with these 632 machine screws. It's number 6 diameter, 32 threads per inch. Good, small little machine screws you can find at most hardware stores. Now you can see it looks kind of ratty back here. I had to cut out a bunch of stuff to actually get access to the lock. But this stuff's basically just made out of like a tough cardboard. And just to protect that cardboard a bit so we don't pull through it with a nut, throw a little washer on here, followed by the nut. Now before I attach this last screw, let's talk a little bit about emergency access to the box. Let's say my electronics fail, or my programming fails, or for whatever reason I can't open this. I don't want to lock myself out of the box. So I need some way that I can open this lock by sliding it sideways without electronics. So this is where we put in our secret way to open the box. What I made here is just a little lever arm here, and one hole I've threaded with that 632 thread. I got a basic set of taps off of Amazon a number of years ago, and it really came in handy here. The reason I threaded that is because I want to attach it to this screw, and I don't want it to be able to spin freely. By having the threads in there, I can sandwich it in between two nuts, tighten it down, and then this thing won't be able to spin freely. It'll be really attached to that screw. So when I turn the screw, this lever will turn. So now all I have to do is hook up a wire from this little key ring over to the lock. Then I can turn the screw and open the lock. Alright, next up, we've got our 4-digit display screen here. I designed this plastic mount here in Fusion 360 and cut it on a CNC machine so that I could line up the screen in just the right spot to show through this opening and match up with all of the mounting holes. Now there's code available for the particle photon or the Arduino that makes it really easy to program these things. So we can just plug that in with a 4-wire cable and it's good to go. So let's mount that in the case next. Next up, we've just got a real basic hobby servo here. And the particle photon has built-in code for working with servos, makes it super easy. But this is actually what's going to be unlocking our box. So this gets mounted over here, and when this arm turns, we'll hook a wire up to the sliding part of our lock. So the servo here can open our lock. And again, I've got another custom designed CNC'd part here for holding down the servo. I've got it designed to fit around the profile of the servo like this. And then I've just drilled and run a couple screws through the bottom of the case here. So we'll mount that down in place next. So with our servo mounted, the last mechanical thing we got to hook up is just to run a wire from the servo arm to the sliding part of the lock. So let's see if I can thread that in there. Okay, we've got all of our functional stuff on the front here. Display screen, locks all hooked up. Now the next major piece here is power and electronics to go inside. We'll slide that into the little battery compartment I've got back here. That'll hold it in place. And since we don't have much space in here, I've got a nice short USB cable to power the Photon. Now, here is the particle photon, the brains of the operation. I'm a big fan of these microcontrollers. I've made a lot of fun personal projects with these. The code you write for them is basically Arduino compatible code, but you're plugged into the whole particle online ecosystem. So I can write code for this thing on a web browser, and because I'm hooked into the particle system, I can go on my phone or through a web API and execute code on this thing, send data to it, read data from it, hook it up to all sorts of online services. There's a lot of fun internet connected capability that you can do with these things. So this is the Photon itself. I've got a Wi-Fi antenna here, and then I prototyped this out on a breadboard, and once I came up with a circuit that I liked, I soldered up this board here so the Photon can plug into it. And I've got pin headers here for connecting all of our devices, like our LCD screen, servo, and then a couple more items for the lights and the button on top. But now we got a nice small package. I didn't actually mount this down to the box anywhere, it just sits down inside. But let's plug it in. And now that pulsing LED there lets me know that it is online and ready to go. These two plugs I haven't hooked up yet. That's for our button and lights that are on the top panel, but we'll get to those later. Now, one other issue is we're kind of limited for space in here, and try to keep things as tidy as I can. So this Wi-Fi antenna, I wanted to keep it up and out of the way, kind of up here. And I figured the easiest way to do that is mount it up with a little 3D printed mount for the antenna. Again, this is another thing that I whipped up in Fusion, 3D printed out, and we'll just screw it into the side here to hold the antenna. Now, with all the complex little pieces here in the lock mechanism and the wires and the unlock here, I didn't want to chance any of my cables or anything else in the box getting tangled up or just getting in the way of this stuff. So I put together just a little shield here out of really thin aluminum flashing and set it up to mount onto the existing screws to protect all this stuff. So let's put that in. So at this point we have the bare minimum for a box that you can unlock over the internet. We've got the locking mechanism itself, a little bit of electronics, some power, a little display screen. Okay. Now, say you've progressed your way through the game, solved all the puzzles, you finally found the mysterious Doomsday device. We got to have some sort of payoff on the inside, something to make it fun. So I was a little bit pressed for time and budget, so came up with something relatively simple. So I've got this piece of semi-transparent plastic that I had scrap of in the garage, cut that to fit on top, and we dressed it up with some colorful blinking lights and a big red button. So the lights themselves are made out of addressable LEDs. I got a strip of 60 of these off of Amazon, pretty reasonably priced. And these things are a lot of fun. This is my first time working with these. But basically you've got 3 wires coming off of your controller, microcontroller, and that feeds into here. And from there you can control each of these LEDs based on an address in your programming. So this is LED number 0, number 1, number 2, 3, 4, and so on. You can cut apart these strips and just then solder them back together here. So I've got strips of 7 rows, so I've got a nice big 7x7 grid. And like I said, since I've got access to a CNC, I made this little plate to sit on top of them. So when I put this under the plastic, I should have relatively square-shaped lights that shouldn't bleed into the other lights next to them too much. So I've got 4 bolt holes in the corners. Let's mount these to the back side of the panel. So the last major component of this thing is the big red button. Somebody finds this Doomsday device, they can push the big red button to deactivate it. Okay. Now, this button's actually been modified quite a bit from the original. So let me show you what it started out like. I did a lot of searching around for big arcade buttons. There was one that I skipped out on because it was going to be too tall. And I don't have a lot of vertical space in this little briefcase. So I found this really flat, low profile one. But the base of it here is really tall. We've got all this space of threading, plus the switch here is way at the bottom, sticking pretty far out. And it is far too tall to fit in the briefcase. So what I ended up having to do was modify this button so the switch itself was actually up next to the button. So let me show you what that looks like. So here is the button that I ended up using. This nut actually had a bigger flange on it that I had to cut off just to make more room for things. We'll set that aside. The button itself comes apart pretty easily here. Take that off. Take out this white piece. Maybe. There we go. There's our spring. Now what you'll see here is an extra hole. This hole was not there before. Since I couldn't push down the center to hit that switch, I'm pushing down on the side. And to get the switch mounted at the side, I actually got the switch here mounted up in a chunk of wood. The switch is in here, and the actual button that it presses is down through this hole. So this lets me mount the switch next to the button, and to actually push the button, got a small wooden dowel that goes down. See if I can line it up here, down through that hole. So now that's how we activate the switch. But you've got that wooden dowel there, and you put all this back in. This is what actually pushes down. So instead of pushing down to the center, it pushes down over here. This took a lot of fine adjustment and experimentation to get everything to fit just right. But in the end, it worked out really well, and it gives me a nice low profile way to mount this whole switch inside a really short briefcase. So let's put this all in. Okay, so we got our lights, we got our red button. Now we just got to hook everything up. So underneath on our red button, we've just got one cable with two wires coming off of it. That'll plug into our circuit board. Here we've got the input wire into our addressable LEDs, so that'll plug into our circuit board. And then, since I only used 49 LEDs here and I bought a strip of 60, I had 11 left over, so I stuck that strip over here on the edge. So while the LEDs over here will be blinking random colors, I have these programmed to just pulse a red light, just for extra effect, since it'll shine through the plastic on the top. So the signal goes into the LEDs here, flows through all of these, and then I've got a line out here to plug into my extra strip down here. So let's get those plugged in, and this thing will be complete. Oh yeah, can't forget to plug in the power. I actually don't have a power switch on this thing. This battery lasts so long, I just planned it out that I would plug it in and just leave it on the whole night, and I wouldn't turn it off until I took it apart again. Now, as I said before, this thing is controlled by a particle photon, And again, one of the nice things about these is it's really easy to connect to them over the internet and interact with your devices. So here is the Particle Photon app on my phone. You can do the same stuff through your web interface. And like I mentioned, for the event that we built this for, we built a website, and the website itself is what actually sent the signal to unlock the briefcase. Because they have a really nice web API, so if you've done any amount of programming, you can peruse their documentation and learn how to write code that can go over the internet and talk to a particle device. But on here, I can go into the functions, and these are functions that I've exposed from the particle photon to the web. So I have a unlock function here, and you have to pass it the correct number from the display screen here. So if it doesn't change on me, let's type it in 3342 and send. Boom, that's unlocked. I've got another function here for testing out servo positions in case I need to adjust how much the servo turns to open the lock. But this code here, that's how I interact with the briefcase over the internet. So in our web app, if you entered the correct passphrase and entered in the number, it would send that number over the internet through Particle's service and down to the device. So that's how we unlocked it. So, hope you found this interesting. It was definitely a lot of fun for me to build. Hopefully it inspired you to tinker around or create something of your own. If you have any questions, feel free to throw them into the comments. And thanks for taking the time to watch, and we'll see you next time.